Hi, my name is Dan Burnett. I'd like to talk with you about identity today. But what is identity? I'm going to show you some photos from my life that represent what I would call different identities that I have. There's my work identity here when I worked on a standard called WebRTC in China. There's my identity here where I went to DragonCon, a fantasy and science fiction convention in the Atlanta area with my daughter, where we got a photo with William Shatner, who played James T. Kirk in the original Star Trek TV show. And then you see me here in my scouting uniform as an assistant scoutmaster with one of our Boy Scouts. And lastly, this is me in Dubai last year on a round the world trip to understand what the challenges were for adoption of blockchain technology. These are all different aspects of my life, and I would argue that they don't overlap very much. They are effectively different identities for me. But the world today treats them like this. And yes, it's a mess. It's one big mash altogether. It's frustrating for me. It's been frustrating for many years that when I go to do anything with any service online, they try to treat this as my identity. They want as much information as they can possibly collect. And I think that's something that we've realized increases risk for all of us as well. Now, I was attending a World Wide Web Consortium meeting, their annual meeting, which they call the Technical Plenary and Advisory Committee meeting in Santa Clara in 2014. This is when I was working on WebRTC. I had some spare time, was walking down the hallway, happened to pass a room in which someone had a slide up on screen that said credentials, not identity. That really caught my attention and I stopped to listen. The person speaking was Manu Sporny of Digital Bazaar, and he was presenting a way to solve problems that people claim they need identity to solve, but without using identity. I walked in after the meeting and said, I want to work with you on this. And he said, well, we may get a chance to bear with me for a moment, hang on for a bit. 1 year later, same exact thing happened. This was at the TPAC meeting in Sapporo in Japan. Walking down the hall, happened to pass by the room, same slide up on the screen. So I stopped and listened again, went in afterwards and said to Manu, I really want to work on this. And that changed my life. That was the beginning of us creating the verifiable credentials work at W3C, which I believe is the solution to this problem. So I want to talk about three different components of this. I want to talk about the ecosystem model that underlies verifiable credentials and decentralized identifiers, and then talk about each of those two technology pieces. The ecosystem that we assume here is where there is an issuer who issues a verifiable credential to a holder. The holder then presents that verifiable credential to a verifier who then verifies that it is valid. In some cases, they need to go to the issuer. In some cases, they don't if you're using zero knowledge proofs, for example. To give a concrete example, the issuer could be your university that is issuing you a digital diploma, and they are issuing it to your digital wallet, which is the holder in this particular example. You then present your digital diploma to a potential employer. They are the verifier. It is up to them to convince themselves that that the issuer did issue this and that they trust the issuer to have done so. And I will get back to that at the end of the presentation. So let's take a look at an example of what one of these verifiable credentials might look like. Well, at that simplest level, a verifiable credential is an issuer who makes claims about one or more subjects and then signs them. And in fact, in the simplest model, it's just an issuer making claims about one subject and signing them. When we talk about this today, we talk about this in terms of three different components. We talk about the credential metadata, we talk about the claim, one or more claims, and then we talk about the proofs. The proofs, this is a generalization of signatures. When we first started, we did talk about signing the claims, but now we talk about proofs because there are a variety of ways to do the equivalent of a signature. So let's look at a specific example of such a credential. So here's one where we have, as you can see here, a university that is issuing a credential that is saying that this particular subject here has a Bachelor of Science and Arts degree. If you notice the credential metadata, we have all of this in red, and that includes the issuer. The claims we have here in green, and the proof part, which I have this bluish purple color for, that's not here. And that's why this right here is only a credential example. It is not yet verifiable. So how do we make it verifiable? Well, one way, and this is the exact same text, I've just removed all of the highlighting for now. One way is to add an ECDSA proof. So if you notice here, what we actually have is a JSON structure. We've got several properties, ID, type, issuer, and so on. And we're adding one more called proof. And this proof contains a proof value that is using a crypto suite, ECDSA RDFC 2019, which tells you it's an ECDSA proof or signature in this particular case. Now, it does not have to be an ECDSA proof. Here's another example, same credential. Notice, no change from here in the credential, from here to here. The credential is exactly the same. The only thing that has changed is the proof. In this case, it is a BBS proof. And of course, the proof value has changed. Now, in both cases, we refer to these as embedded proofs because they are just another property within the overall structure. So the proof is included along with the rest of the credential. But it doesn't have to be that way. And in fact, there are people who very much like using JOTs or JWTs, where this information may be presented in different and split up into different pieces. So with JOTs or JWTs, you typically will define some headers. Right here, we have the credential. If you look, this is actually the exact same credential that we had before, media type application/VC. That would be in one file, for example, and then in another file, application/VCLD plus JWT, you have this right here, which is the proof. So they're not together in the same file necessarily, but the credential is the same. Okay, let's take a look at the identifiers. I really want to talk about this because this is the other piece that is critically important. If you look here, same credential on the left, but I'm showing three different identifiers. There's an identifier for the credential itself that is issued by the university. There is an identifier here that is for the issuer, and the issuer is the university. And then the last identifier that we have here is for the subject itself. Now, why do we need this? Okay, we already have the ability to use URLs, email addresses, Facebook and Google logins already exist. Even though I don't like login with Facebook and login with Google, you can already do that. So why is it that we need something new? For all of the examples that I just listed, URLs, email addresses, Facebook, Google logins, etc., all of the identifiers here are not yours. They are leased to you by someone else. Someone else controls them. Typically, there's a central authority that controls the issuance of those identifiers. And not only can they take that identifier away from you without your permission, they can even assign it to someone else, which is much worse, right? One interesting example of this is if you are Google in China, it's very apparent that you do not control google.com in China, because if you try to go to google.com, it will not take you to Google's websites. And that's something that it is inherent in how the domain name system works. It is hierarchical, and local entities such as regional governments do have an ability to not follow some of the internet protocols and intercept communications. So we realized that we needed an ability to have an identifier that was yours, that no one could take away from you, and that would always exist for as long as you wanted it to. And that's what led us to the notion of decentralized identifiers. This is right when blockchain technology was beginning to take off. And so we realized that it was possible to create identifiers that that existed merely because they had some connection with something happening on a blockchain. And that as long as you had the control over the keys, they were under your control. So let's look at some specific examples of what DIDs look like, or decentralized identifiers. Officially, they are uniform resource names. Now, you may be familiar with uniform resource locators or uniform resource identifiers. Those are URLs and URIs. URNs are similar in terms of their structure. They begin with a scheme, which is the first part here before a colon. What follows that is typically a namespace of some sort. This is true for both URIs and URNs. But in the case of URNs, you then have another colon, and then you have a namespace specific string that follows it. In the case of a DID, what we have, this is a decentralized identifier right here. We have defined the DID scheme to allow for a DID method, which is what goes between the next, these two colons here. We call it a DID method, by the way, because the method describes how you get from your method specific string that follows to an understanding of what the identifier actually is. Because this is specific to the method, this particular string, you need some explanation of how that actually gets resolved. So one of the things we talk about a lot is resolution versus dereferencing. This applies to URIs as well, and you can check out the RFC 3986 that describes this for URIs. We largely follow that. Resolution is the process of figuring out what kinds of things can be done with your resource that's identified by the identifier, whether it's a URL or, in this case, a DID. And dereferencing is the process of actually taking actions. In the case of a DID, for example, it might be that we actually have an ability maybe to make a call to that DID, or maybe to transfer money to that DID. And so resolution would tell you what kinds of capabilities are possible, and dereferencing would then be taking those particular actions. I want to just briefly cover what are the key properties that make something a decentralized identifier. And before I get started here, I should point out that not all of the things that people are calling decentralized identifiers actually satisfy all of these properties. That's okay. I'll talk about that more in a moment. Obviously, for a decentralized identifier to really be decentralized, it needs to be decentralized. And that means no centralized registration authority required. This is a property that is broken by some of the DID methods that you will see today and in the world today. Some of them are quite centralized. We know that we need that as something just temporarily to get people used to the infrastructure. But to really be a decentralized identifier, this property is obviously important. The next one is that it's important that you can prove control over that identifier using cryptography. And so that's something that we do require if you really want to call it a proper decentralized identifier. I mentioned resolution. It must be resolvable. You can look it up to discover what kinds of things you can do with this particular identifier. Lastly, it's permanent. It's unique. It will continue to exist, and it never needs to change. Now, that doesn't mean that it might not be deactivated or decommissioned in some sense. But what it usually means is that no one else will get that identifier. And you basically you have an ability to prove control over that identifier. And unless you give that control to someone else, they can't get it. They can't take it away from you. Now, this also doesn't mean that you can't rotate keys. There are a number of DID methods that permit the keys that you use to be rotated without the identifier itself changing. And that's actually a really useful property, it turns out. I want to give some examples of DID methods here. The first one, DID Ether, actually uses an Ethereum address. So this is an Ethereum address right here. And I've listed here the GitHub repo where the DID method is defined. DID Web is another example of a method that exists today, and you can follow it just by your domain name, okay, example.com. How that is resolved and how that works is defined in this particular GitHub repo here. It's obviously not decentralized, okay? But it turns out that it's convenient for people who are getting started because they understand how this works and they can change their infrastructure to use something like did web. And then when they're ready, they can go to more decentralized methods like did ether or did BTCR. This is a Bitcoin transaction ref. And this is the GitHub repo that defines how that did method works. Lastly, I've got did key. This is basically just a public key that's part of a public-private key pair. Obviously, you cannot rotate keys with this method, but it's super simple. It turns out that did web and did key are two of the simplest and easiest for people to understand. Um, and did key is useful for certain things like peer-to-peer communication and whatnot. And there, right here, there's also a GitHub repo defining this did method. Want to give some examples of deployments of verifiable credentials and decentralized identifiers. The U.S. Department of Homeland Security is providing credentials for permanent residents and naturalized citizens using did web, or they'll begin doing it soon. They're working on that right now. TruAge, let me explain a little bit first. In the US, if you wish to buy alcohol, you have to prove that you are over the age of 21. The way this normally works is that you would present your driver's license, and the person would look at your birth date on that driver's license and do a calculation and figure out whether you're over 21. The problem with this is that your driver's license also contains your height, your weight, your eye color, your hair color, your home address, all kinds of personally identifiable information. You may not wish to really be sharing that information with the person at the retail store. So what TruAge does is they have a method for allowing you to prove that you are over 21 without giving that other information away. And they use DidKey in order to do this. Bhutan has a national digital identity. They use the did method, and this is to enable peer-to-peer digital transactions. Then we have Privado, which used to be Polygon ID. This is not really a deployment so much as it is a framework. They provide verifiable credentials for age verification, national ID, content authenticity, and other capabilities. And they use the Polygon ID method. But they have said that as soon as they can tell which did methods are being used by others, they will support those as well. The last one I want to comment on is Glyph. Glyph has been around for a while. They've been providing legal entity identifiers for corporate entities for a long time, but they are now also providing them as DIDs using did webs, and there have already been more than 2.7 million issued. So I consider this a major success story. If you're interested in the work, the best place for you to start is actually the credentials community group. This is a fairly open group. There, you have to sign up, but there's no fee or anything like that to participate. They're very beginner friendly. You can ask newbie questions and they will be happy to help you out. If you get to where you're interested in participating in the development of the standards that I've described, these are the two groups that do that define the standard specifications themselves. And lastly, I want to comment on the did method registry. This is where you will find the list of all of the did methods that are currently registered. Unfortunately, it is right now in the process of moving. We're moving it from the CCG to the did working group, the decentralized identifier working group, because we need to update and improve how that process works. And so right now, if you go here, the links that you find may actually not work. Give it a month or so, and then everything will have addresses that are working. And finally, the last thing I want to say is that verifiable credentials are designed to make clear the separation between what is cryptographically provable and what is a human policy decision. If you notice in all the examples, the verifiable credentials I talked about don't provide any guarantee of truth of the assertions. What they provide is a guarantee that the issuer made those assertions. Whether you trust them is up to you. This is always true. Anyone who asks whether claims are true is falling into what I call the trap of identity. The right question here is whether you trust the issuer to make the claims that you can prove they did. Thank you.